In this question, it says that what is the oxidizing and reducing agent given the following reactants, and this produces this product on the right side of the arrow. To accomplish this, we have to follow the specific rules in order for we to determine what the oxidizing and the reducing agent is. And the key rule here to remember is known as investigating the oxidation number, and this oxidation number for each of the species and the rules will enable us to highlight what the actual oxidizing and the reducing agent is. And so the solution is as follows. First is that in here we're given this reactant. We're going to see what the oxidation of this oxidation number or the charges that are present in each of the elements in this reactant. And so here first is that we know that the total charge of this particular species here is equal to 0, and since we have that highlighted, we can now proceed by writing our tin, and we're going to add it to what we have. How many fluorides? We have 2 fluorides, and so this here we know that for fluoride its oxidation number is always -1, and this here is equal to 0. Therefore, when we solve for our tin, we know that our tin's charge here at the reactant is what? +2. And so that is awesome to be aware of. So we're going to write to keep track of our tin here to be +2, and our fluoride we know that it is -1 in terms of the charge. Now the next part here is looking at our lead fluoride, and this here shows that for lead we have just 1 atom here, but we are adding how many fluoride atoms? We have 4. And so here we know that always, because fluoride is the most electronegative element in that compound, that is showing that it's going to have its charge to be -1, and therefore this here must be equal to 0, because the sum of all the charges in this atom or compound, because it is neutral, is equal to 0. Therefore, in here, to solve for our lead at the reactant end, we realize that lead here is what? +4. So its charge here is 4+, and in this case fluoride we know is still 1-. So let's look at the product end. So we are done here with the reactants, and so for the product, let's see whether the tin ion is going to change. And this here shows that for tin, when we add it to what? We add it to, we have 4 of the fluorides. In this case for fluoride charge, it is -1. This here is equal to 0, because here the net charge here is equal to 0. Therefore, this results in our tin's charge to be equal to +4, and that is shown right here, 4+ for its oxidation number, and for fluoride its oxidation number is -1. On the other hand, when we look at lead 2 fluoride, in this case lead here, we're going to be adding how many fluorides? We have 2. How many that fluoride is -1 for its charge, and this sum must be equal to 0. Therefore, this shows that our lead here charge is equal to +2, and this is our product charges for the elements that are not fluoride. And so this is quite interesting, because now we can see some interesting changes. We see that our iron is changing from +2 to +4. This shows that this here, which is our tin, is increasing in its oxidation number, and for our lead here we notice that it is what? Decreasing from +4 to +2. And so since we see these changes in oxidation number, but we notice that our fluorides are the same in terms of the charge before and after, or in this case at the reactant and product end, we have two species here that we're going to analyze as to whether it is an oxidizing or reducing agent. Now, what we know is that for oxidation number to increase, that shows that that species is oxidized, and on the other side here, when there's a decrease in oxidation number, the species is reduced. And so therefore, in this case, because tin is oxidized, it causes the reduction of our lead, which makes our tin here to be a reducing agent. However, because we have our lead to be oxidizing our tin, that makes our lead to be the oxidizing agent. So I hope you found this really informative in terms of how to determine the oxidation number of different species in a reaction, and based on the oxidation number we can determine what the charge is for each of the species, knowing the specific rules, and then finally comparing the before and after oxidation number of a species to determine which one is the one performing reduction, in this case lead, and the other one performing oxidation, which in this case is tin. And then finally we can conclude that the reducing agent is the one that is oxidized, and while the oxidizing agent is the one that is reduced. Hope you found this really informative. Please hit the comment down below, let me know your thought about this. By that way I can talk to you soon. Stay smart as always and believe in yourselves.